Problem 21. Because the rectangular array has 40 rows and 75 columns, and the average of the 40 rows is A, therefore the total sum of the numbers in the array will be 40 multiplied A, and it also equals to the average of the 75 columns B. 75 multiplied P. B is also the total numbers sum in the array. Therefore, we simplify this, we can get A over B equals 15 over 8. The answer is D. Problem 22. So it's a 3-digit number, and each number can't be 1. Therefore, we can choose from 0, 2, 3, 4, 5 till 9, and that's 9 choices for each digit. Therefore, we will have total 9 multiplied 9 multiplied 9 equals 729 choices. And notice that in all these choices, we counted 0, 0, 0 in there, which is smaller than 1. Therefore, we need to subtract this choice from the total number of choices, and that's 728. The answer is D. Problem 23. Let's assume the number of boys is B and the number of girls is G. From the problem, we know that there were 2 more boys than girls, so B equals G plus 2. And because Mrs. Wonderful gave each boy as many jelly beans as there were boys in the class, so that's B squared plus she gave each girl as many jelly beans as there were girls in the class, so that's plus G squared. It equals 400. Subtract the 6 jelly beans left. Therefore, we substitute the first equation into the second one. We can get it's G plus 2 squared plus G squared equals 394. And we simplify this, we can get it's G squared plus 2G plus 1 equals 196. And this part equals G plus 1 squared equals 196. And from here, we can solve it. We get G equals 13. Therefore, B equals G plus 2 equals 15. And the total number will be 15 plus 13 equals 28 students. The answer is B. Problem 24. From the first operation, we know that B plus A equals A. It can't be 1A because B is smaller than 10. So B plus A equals A, which we can get B equals 0. Therefore, from the second equation, we can get it's 10 subtract A equals A. And we get A equals 5. Therefore, A is 5. B is 0. And here A is 5. A is 5. A is 5 here. B is 0. A is 5. 5. And again, from the first equation, we know that A plus C equals D. And from the second equation, we know that B borrowed 1 from A to subtract the A underneath. So then A is left with 4, and A subtract A minus 1 subtract C equals 0. This means C equals 4. So we can put C equals 4 in both equations. And that means A plus C equals D. We get D is 9. Therefore, the answer is E. Problem 25. From the problem, we know that the 1 cubic foot cube is cut into 4 pieces A, B, C, D, and their height are labeled on the graph. And then we switch them and rearrange into the following figure. Now we would like to know what's the surface area in total for the second configuration. First, we calculate the top and the bottom area. Because the lengths of these lines are all 1. Therefore, the bottom length in total is 4. And this width is 1. Therefore, the top and the bottom area will add up to, we use T for top, B for bottom. It adds up to 1 multiply 4 multiply 2 equals 8. And then we calculate the left and the right side, the area. The area on the left and the right side are identical, so for the right side, we will have these 4 heights adds up to 1, and multiply each of their lengths. That's 1. So left plus right equals 1 multiply 1 multiply 2 equals 2. And then we calculate the front side and the back side. Front plus back. We can observe that this area and this area and this area will add up to this height multiply this length. This is 1 and this is A, its thickness is 1/2. So that's same. For the back area, it will add up also this 1/2 multiply this length. And that is 1/2 multiply 1 multiply 2 front and back equals 1. Therefore, 8 plus 2 plus 1 equals 11. Therefore, the total area should be 11. And the answer is E.